Let's wait for 1 or 2 more minutes. Is it okay?
Okay, sir.
Okay. So as I have already mentioned in the WhatsApp group, so today we'll start solving some design related problem. Okay. For that, what I want to do, you people, is you download that particular design related solve example that has been shared in the Google Classroom, and I hope all of you are ready with that thing. Okay, so what I will do, so that solve example we'll first see. Okay, they are in right now for this class or for today or tomorrow's next class. Basically, I have shared two examples, one from the knife edge type of follower. Okay, so we'll be discussing with respect to like reciprocating followers only. Reciprocating followers, I hope all of you already remember. So reciprocating follower, what happens in case of reciprocating follower? Anyone? How can you define it? Reciprocating follower. You remember? So basically, it's based on the movement of the follower, which it is getting in the run, like you can say diamond follower and whatever we have. Based on that, if the follower is reciprocating within a certain guide, okay, so if the motion is like that, then it's reciprocating. So from our syllabus point of view, we'll be restricting our discussion with respect to reciprocating type of follower only, but we can deal with I have given you two examples, one from knife edge type of follower, where we will see that the follower that we are going to use is knife edge type. Okay, I believe all of you already remember. And another one example I have taken from roller follower. Similarly, I hope all of you remember what is inline follower and what is offset type of follower. Do you recall it? Because these are the basics that we'll be needing while going for constructing cam profile. Anyone? You remember inline type of cam and follower arrangement and offset type? Don't hesitate to answer. I'll not be judging you because whatever you recall. Anyone? You can unmute and so in inline arrangement of cam and follower, what basically happens? We have the cam and the follower. If I consider this as the cam, okay, which is rotating about, suppose this particular shaft is there. Okay, so this is the center of the cam. Okay, and if I have the follower somewhere here, suppose if it is knife edge follower, suppose it will look something like this. Okay, so don't mind the drawing. So it's not that good. Okay, so what is the, suppose this is the center of reciprocation for the, in the case of our this follower, right? So this is reciprocating like this in this direction. Okay, and the cam is, this is the cam, right? And this is the follower. Okay, this is the cam, this is the follower, and this is the guide, right? So this is a reciprocating type follower. We can very easily see. Okay, reciprocation movement is there in the follower. So this is what type of follower? This is knife edge. From the look we can say knife edge. Don't mind the drawing. Okay, and in this particular case, anyone tell me whether it is inline type or it is inline or it is offset type? I am audible, right? Yes, all of you hear me, right?
Sir, it is inline. Yes, sir.
Yes, correct. It's inline. Okay, and now correct. Okay, so now these things, why I'm just these are some of the basics that will be related, because in the question, if it is said it's if it is inline type, whether it is offset type, based on that we should be able to categorize them. Okay, and now what about offset type? If suppose this particular thing, okay, if it is somewhere here, okay, or somewhere here, okay, if the follower location is here, here, or whatever, okay, that is, it is not coinciding the, in the case of inline case, okay, the axis of reciprocation or movement of the particular follower, it passes through the rotation axis, cam rotation axis. Okay, so they coincide. And if it is not happening, if the situation is something like this, okay, then axis of reciprocation of the follower is somewhere here. Okay, and now the cam rotation axis, okay, it is somewhere here. Okay, about this point actually axis it is rotating. Okay, so now there is this much eccentricity is there. Okay, so then what kind of arrangement is this?
Offset, sir.
Yes, correct. Then it is offset type. Okay, so in the questions you have to see with what kind of things are being discussed. Okay, so you should always go through the question properly. Then what are the things you should try to say? Okay, if first, most of the time generally the angle of ascent, it is generally given phi suffix a, angle of ascent, those things are generally given. You will be able to find out. Okay, then dwell period is generally given. If it is there may be one or two dwell. Then if it is dwell 1, that first dwell delta 1, then if it is another dwell is there, you can use delta 2. Okay, like that. And similarly descent stroke angle, you can, that if it is that is given, then phi. And sometimes some of the angles might be given, the other angle, one of the angles it might not be given. Okay, maybe suppose ascent is given, descent is given, and said that only there is in between only one dwell is there. In that particular case, how to find out the angle, this dwell angle? If suppose it is said that suppose 100 degree is the rise angle or the ascent stroke angle. Okay, maybe there is a like the dwell involved in between. Okay, suppose 40 degree or 50 degree, suppose. Okay, suppose after that there is another descent stroke is there. Okay, phi d, suppose it is also given as suppose 150 degree. Then what will be the delta 2? Will there be any second next dwell? Can anyone tell me? Suppose ascent stroke angle is 100 degree. The dwell between ascent and descent is suppose 50 degree. Then the descent stroke angle is suppose phi d is 150 degree. So do you think there will be another dwell that is delta 2? Or if it is there, how to find it out? Anyone from your common knowledge? Anyone would like to try? Okay, so in this particular case, you will just go through the angles, whatever is given, and we already know if we talk about the like if you are talking about this movement of the cam and all. Okay, if we are discussing about, suppose we are going through the displacement diagram. Okay, then in that particular case, we show it for one complete revolution of the cam. Okay, that is 360 degree. So in that particular case, 360 degree minus this plus whatever is the addition of all those angles that you can do, and you can find out the whatever is the next delta dwell. Okay, so these are some of the bases. Understood up to this much? Anyone any confusion? Just let me know. I hope you have understood. Yes or no?
Yes, sir.
Thank you. So next thing that you should see is whether what kind of motion it is talking about. Okay, in the question something will be, suppose SH stroke will be with suppose SHM motion, or suppose some other type of motion. Okay, whatever be. So you should look for the scheme of movement. Okay, because see, what is from our previous knowledge about cam profile construction, what we recall is basically there are main two steps involved in the cam profile design. Okay, first one is you should be able to draw the displacement diagram for that particular question. Okay, for that particular situation. Okay, by considering whether it is what kind of movement is there. Okay, whether in the ascent stroke, in the descent stroke, if both the type of scheme of movement of the follower is same in both the ascent and descent stroke, maybe you can go for directly the standard ways that we already have discussed. That way you can draw the displacement diagram. Sometimes it may so happen that in the ascent stroke there is one type of scheme movement, suppose SHM. In the descent stroke it is said that suppose it is descent stroke which suppose angular acceleration, like uniform acceleration and retardation. So that may also happen. So in that particular case, while drawing the displacement diagram, you should be careful. You should SN stroke only you should be able to draw about, just like SHM. Similarly, whatever is the scheme of movement given for the descent stroke, you should follow as it is. Okay, so those are the main things that we will see, and after that, the angles etc. we'll just find out. We'll note down whatever is given. If some angle is not given, we'll try to find it out. Okay, and then based on what kind of scheme of movement is given, based on that, by comparing proper scale, that is important, very important. Okay, so while drawing, because these are all, if you are talking of construction or drawing, okay, these are nothing but what kind of methods are they? These are graphical methods. Yes. So because of that, so if you can recall from your last class, so today you should have your geometrical instruments with you, so that you can at least try. Okay, so these are graphical methods. Okay, and now in that particular case, if you're talking of graphical method, then proper scale is very important. Considering proper scale is very, very important. Okay, it has to be taken and it has to be mentioned. Okay, mention the scale taken. Okay, this is very important. It should be proper and you have to mention it, and whatever you mention, based on that you should draw. Okay, so now I believe all of you have your that note ready, and we can discuss with respect to it. Yes, all of you have your note ready, that what has been shared in the solve example that has been shared in your Google Classroom. Just let me know, one of you. Anyone can unmute and just let me know.
I have.
Okay. I hope it is the yes. I hope same is the case for others also, and also try to be ready with your pen, pencil, paper, etc. so that at least you can see how to. So now the first example will just first always we have to see what is being given. Always your first task will be to like look for the main important data that has been provided in the question. So now what is the question? We'll just read it once. So draw the profile of a cam operating a knife edge follower. So first important thing that you have found out from the question is it's a knife edge follower problem. Okay, operating a knife edge follower having a lift of 30 mm. So what do you remember by lift? So this is nothing but we can denote it with either X or H. Okay, so that is the lift, that is the movement to highest displacement of the follower. Okay, from its position. So here the given data will just these are the given data. Okay, so the given data we will have to write down. Okay, once you go through the question, you will get the of those values etc. and we will find out that. So next it is draw the profile of a cam operating a knife edge follower having a lift of 30 mm. Okay, the cam raises the follower with SHM. So that means the rise stroke is with SHM. Raises the follower with SHM for 150 degree of the rotation. That is 150 degree of the rotation means it is a rise stroke angle, theta or phi a, whatever you denote. Okay, so that is ascent stroke or rise stroke. Okay, those are same. So raises the follower with SHM. So for 150 degree of the rotation, this is with SHM. In bracket you always mention what is the scheme of movement, so that later on you don't make mistake while drawing the displacement diagram. 150 degree of rotation followed by a period of 12 or 60 degree. So next, that means after rise stroke we have the first dwell delta A. What is the angle? 60 degree. Next, the follower descends for next 100 degree of the rotation of the cam with uniform velocity. Now the scheme of movement for the descent stroke, it is not the same. Okay, so angle of descent is given. If it is follower descends for next 100 degree means this 100 degree is the angle of descent, phi d 100 degree, and in bracket you always mention what is the scheme of movement, that is the uniform velocity. Okay, right now I am using UV, don't mention like UV, you write down uniform velocity. Next, again followed by a dual period. So that means after that there is another delta. Okay, so that is second delta is there, delta 2. So but the value is not given. So how to find out the delta 2? We know that one complete revolution is 360 degree. So 360 degree minus all this. Okay, 360 degree minus all this will give you delta 2, that is 50 degree. Okay. Next, the cam rotates at a uniform velocity of 120 rpm. So n is given. Okay, n is 120 rpm and has a least radius of 20 milli. Okay, so RC, that is least radius of cam, that is also given. And this least radius is nothing but it gives you the base circle. Okay, ultimately it gives you the indication about the size of the cam. Okay, so least radius is 20 mm. Now, based on this value, you have to draw the profile of a cam. And after that, some question also is there. What will be the maximum velocity and acceleration of the follower during the lift and the return? During the lift and the return means in the right stroke and in the return stroke. So for finding out the maximum velocity, acceleration, okay, for all those like SHM motion for uniform velocity, we already have the known equations that already we have seen in the while looking for, while we have discussed about your this one, what to say, like construction like displacement diagram for various scheme of movement of the cam. Okay, so those known formulae you can directly use, but remember while using those formulae, okay, so all those angles, okay, you have to convert to radian, angles in radian only. Okay, while using the formula, use the convert the angles in radian. Okay, so up to this much, any confusion, anyone? How we have obtained those things, given data? Just let me know. So these are the main things that you should okay, and mention what is the type of always mention what is the type of movement for ascent stroke. In bracket you can write, okay, just like with the angle similar to descent stroke. Sometimes both of them may be same. In this particular question, it is not the same. That means we should be able to draw in different ways. Okay, I hope up to this much it is clear. And mention what type of follower is this. So knife edge follower. Okay, knife edge type of follower. Okay, just let me know whether you have understood or not up to this much. I hope there should not be any problem.
No, sir.
Okay, thank you. So next, we are ready with all the data, and now we should be able to draw the cam profile. And after drawing the cam profile, or before drawing the cam profile also, that is up to you, as we already have the standard formula for finding out the maximum velocity and acceleration for ascent stroke and for the return stroke. So we should be careful. For ascent stroke, it is given as SHM. So the formula for SHM motion we should use, and for return stroke it is given as uniform velocity. So corresponding formula you have to use. Okay, those care that was care you should take. Okay, so I hope all of you are clear with this. So next, our scheme is we already know that. After that, what are the main steps involved? First, we should be able to draw the displacement diagram properly for this case. Next, by taking the some corresponding values from the displacement diagram, we should be able to draw the cam profile. So those are the main two steps. So now we will come to the how to draw the displacement diagram in this particular case. So now, just can anyone tell me, while drawing the displacement diagram along x-axis and along y-axis, what are the parameters that we consider? Do you remember how to draw a displacement? What are the parameters, or what are the variables that we consider in the x-axis or and y-axis while drawing a displacement diagram? Anyone can unmute and let me know. So along x-axis we consider the cam angular movement, that is theta or phi, whatever you denote with. Okay, and along y-axis we denote the lift of the follower, x or h. In this problem, in the question they are using h. Okay, x or h, whatever you use, ultimately this is nothing but the lift. Okay, so now we are already ready with all those angles. We already know, like, what is the phi a or theta a, what is the delta, first delta, what is the descent angle. Okay, these things we already know. So what will be our how to draw it? So first, initially, just like the previous construction of your displacement diagram only, but right now we have got the values. So in this, initially we should look at the values, and we have to consider a proper scale. Okay, along x-axis and along y-axis. Okay, so along x-axis will mention, suppose what are the angles given? So phi A is 150 degree, next one is 60 degree, and 100 degree. So maybe you can consider 20 degree along x-axis, 20 degree or 25 degree or 30 degree, whatever, as the suppose 1 centimeter. Okay, because we are going to draw in length terms, but along x-axis the length denotes angles. Okay, so along x-axis suppose 20 degree or 1 centimeter equal to 20 degree, or 20 degree equal to 1 centimeter we have denoted. Okay, so in that particular case, and similarly look at the what is the value of the lift that is given. So it is given as h equal to 30 mm. So directly you can consider y-axis like 1 mm is equal to 1 mm only. So in the previous case it is degree, but in the case of y-axis it is lift, it is the displacement, so in millimeter only, and we are also drawing in the lengthwise. Okay, so 1 mm equal to 1 mm, or 1:1 you can write like this. Okay, y-axis 1:1. So along x-axis, if we consider 20 degree equal to 1 centimeter, so to denote theta A or phi A 150 degree, how much length it should be? How much I should draw? Okay, we will be first drawing the x-axis and the y-axis. We'll mark it definitely. From there we have to mark them. Okay, so if 20 degree equal to 1 centimeter, we have to mark at 150 degree. So what will be this length?
7.5.
Okay, so 7.5 centimeter at 7.5 centimeter you have to mark. Okay, and this much is you have to denote it phi A, that is the ascent stroke angle. Next, what we have along x-axis, we have got the dwell. Okay, so now dwell is how much? Dwell is given as, first dwell is 60 degree. Okay, so 60 degree I have to draw. Then where I have to mark it? I have to draw once again, because 20 degree equal to 1 centimeter, you cannot now change along x-axis. It will remain the same scale. I have to draw 3 centimeter. Okay, yes or no? 20, 20, 20, 60. Okay, similarly, next is our dwell, not dwell, descent stroke angle, and that is given as 100 degree. Okay, so 100 degree is the next dwell. So that means I have to mark here up to 5 centimeter. Okay, and by doing after that, just delta 1, phi D, those things will mark. And next we have another dwell delta 2, and as a dwell is there at the end, it is up to you. If you want to show the dwell, you can do so by extending here, but it will, as it is dwell, it will after descent. If it is dwell, then it will remain here only. There will not be any displacement. So at the end, after dwell, if there is another dwell, it is up to you whether you want to show it or not. Okay, so you may not show it, there is no problem with it, because after that there is actually no movement, it will be just like flat. Okay, up to this much all of you have understood? Just let me know, someone. I hope yes. Okay, next, what is our task? Next, in the y-axis also you have to mark the thing. Okay, so lift is given as it was 30 mm. So we have considered 1:1 ratio. So 30 mm you will mark. Okay, or you can increase or decrease whatever as per your convenience. Okay, it should the figure should be such that it should be within the page limit also. Okay, and it should look in a proper scale. It should be proper scale, and the proportion should be, it should look good. Okay, so like that. So 30 mm you can mark here, or maybe 30 mm you can make it like something 60 centimeter, like 6 centimeter or 3 centimeter, whatever you want to do. Okay, so like that you will mark here. After that we have to complete this particular box. Okay, rectangle is complete. Then here we have it was ascent stroke, it ends here, or dual starts here, so we'll mark here. Similarly, here it's the end of the dual stroke or starting of the descent stroke. So that has been done. Up to this much, I hope it is clear. Next, what was our task? We actually have to get the curvature nature. Actually, we should divide the ascent stroke and descent stroke into certain number or even number of parts. Okay, so for doing so, what we are going to do is, so first as per the question, ascent stroke is with SHM, descent stroke is with uniform velocity. Okay, so for SHM we already recall. Okay, we have to suppose we have dividing it into 6 equal number of divisions. So 7.5 centimeter, we have to consider divide by 6 and mark accordingly. Okay, so make 6 division equal space division, and starting from 0, so mark down 1, 2, 3, 4, 5, 6. Similarly, you divide, suppose in 6 number of division, 8 number of division, the descent stroke also. Okay, so why we are starting with once again 6, because this is the duel. So whatever is the initial position means at the starting of the duel, that is the same position at the end of the duel. So you can start from 6 numbering, or you can go for 7, 8, 9, 10, no problem. So that is up to you. So here also we have made 6 equal space division, 6, 7, 8, 9, 10, 11, 12, like that. Okay, and now as ascent stroke is with SHM, so for drawing the displacement diagram for SHM, we already recall the considering the lift as the diameter from the center position. Okay, we are going to draw the semicircle. We are going to divide the semicircle into 6, as we have divided the ascent stroke into 6 equal space. So this semicircle also we are going to divide, mark in the 6 equal space division. So it is angular division. Next, after from there we are going to draw the horizontal lines. Okay, this, like this, and it is already there. Next, to locate the points, so from the first horizontal and first vertical we'll see. So this is the point. Second horizontal, second vertical, this is the point. Second, third vertical, third horizontal, this is the point. Okay, fourth, for fifth, and for sixth it is this point. Similarly, during duel we don't have to divide anything, because during duel there is no like whatever is this position in this position. Okay, whatever is this location, from this location there will not be any movement. So throughout the duel it will be something like this. Once again, after at the end of the duel or at the start of the descent stroke, this is the initial position and we are falling down, that is the descent stroke. Now in the ascent stroke, as we have already denoted the points, so mark the points 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash accordingly, and join freehand by using a freehand and with a smooth curve from the starting point. Okay, so this becomes the, if you join the line, okay, this gives you the curvature. After this is you just darken it, and in the descent stroke, what is the type of movement? It is uniform velocity. So in case of uniform velocity, we already know. Okay, so with a gradient of 45 degree, basically coming down. Okay, so if you join like this, then also it will be like as it is going down. So we'll start from this side. Okay, so as from the uniform velocity case, we already know. So making 45 degree, basically it's slow straight line with this particular gradient. So all those wherever the division of this line divides or meets with the vertical divisions, you have to mark the points accordingly. So 6 dash, this 7 dash, 8 dash, 9 dash, 10 dash, and so on. Okay, and you have to join it. Okay, so this is for ascent stroke, this is for descent stroke, and I hope all of you have understood how to draw the displacement diagram. If any confusion is there, let me know. So all those points should be corresponding points. Okay, for one first division we are giving 1 dash, 2 dash. You can also go for A, B, C, D, like that. Whatever the nomenclature you use here, similar is the way we are going to do in that case of our your chem profile. Okay, just let me know, have you understood or not?
Understood, sir.
Okay, thank you. So in this particular case, all these assumptions you have to write down. Okay, assumptions are clear. Next, we are going to, this is the displacement diagram that is over. Okay, we have drawn the displacement diagram. Next, we have to actually draw the chem profile, taking help from the displacement. Okay, so now for that, what we have to do? So we have to, first step will be to, you have to draw a circle with radius RC. So RC is already given. So here it is given as 20 mm, considering RC, that value. So next step is to draw this particular circle. Okay, this circle, considering this. Next, we will show the location of the knife edge follower. Okay, we'll consider this particular line. Okay, you can take any starting point, but taking starting point as the vertical position, it makes your things easy and looks also is better. You can even start from there, but actually that will not be the case because it will fall down like this. So it's better if you show the follower here. Okay, understood, I hope. Okay, so knife edge follower will just show here. And as nothing is being said in the question whether it is inline or offset, so to make our task easy, we'll consider inline type of cam and follower arrangement. Okay, so those assumptions you will just write down. Okay, so assumption you will write down now. RC taking RC, we have to draw this particular thing. Okay, so as it is knife edge follower and the trace point itself is at the knife edge itself, and if it is the minimum radius of this particular cam, so in that particular case we are directly considering from our previous knowledge we already have discussed. That means in this particular case the circle that we have to draw is the value will be RC only. Okay, there will not be any ruler and all. If it had it been ruler follower, we have to consider the this dimension of the circle as RC plus R if it is ruler follower. But here, as it is the trace point itself is located here, so it is only RC. Okay, because it is knife edge follower. So knife edge follower will just show, okay, and this particular division. Okay, first position initial. Next, the assumptions, in the assumptions you must write down. If you recall, what is the thing that we use? We use the kinematic inversion. The kinematic inversion means we consider as if the follower cam is stationary and follower is rotating around the cam. That is what we consider. Now nothing is being said. Suppose cam is rotating in clockwise or anti-clockwise. You just consider as if that assumption you just write down. Considering cam is rotating in clockwise direction, we are considering the follower is if is rotating in the anti-clockwise direction. Okay, so that assumption you will just write down. Okay, cam is stationary and the follower rotates about the cam in the counterclockwise direction. Now starting, as this is our starting position, so we already have theta A, delta, theta D, etc. So from here you just make the division. So theta A, it was given us I think 150 degree or so, 150 degree. So this much is theta A. So this is theta A or phi A. After that there is the dual. Mark the division, mark it. Similarly, after that theta D was there for 100 degree. So from here it is 100 degree. It is 60 degree for dual, and last remaining thing will be delta 2. That is the second dual. So that is the division. It is done. Next, whatever is the number of division you have done in this displacement diagram in the ascent stroke as well as descent stroke, similar number of same division you will be making in this particular diagram also, in this circle. So this is 160 degrees, so 6 equal space division you will be making. Okay, these are regular division. So you will mark the points here in the circumference, okay, in the periphery, and join lines. Okay, so 6 divisions. So 1, 2, 3, 4, 5, 6. In the descent dual stroke, you don't have to make any division because it is meaningless. Okay, because throughout the dual there is no movement, so it is constant radius curve. That means we already know. Okay, dual means there is no displacement in the follower, and when does it happen? Whenever we meet a constant radius curvature, there is no change in the distance. Next, once again, this much is our which angle? This is the descent stroke angle, and in the displacement diagram also we have made 6 division. So 100 degree you have to mark it with 6 equal space division, and you have to join the lines. Okay, so these lines are being joined. Okay, so divisions are being done. Again, in the dual we don't have to do anything. Okay, up to this much I hope the division it is clear to everyone, and you just make the whatever names you have used here. Suppose if it is 1, 2, 3, 4, 5, 6, use the same division here, 1, 2, 3, 4, 5, 6, etc. Similarly here it starts with 6, we will start with 6, 6, 7, 8, 9, 12. Okay, so it corresponds to the displacement diagram. Okay, so that's why drawing the displacement diagram properly is very important. Next, the last step is remaining. Okay, so last step is what we have to consider. Why we are saying that the displacement diagram should be proper and should be taken care of with proper scale and all, because the lift of the follower is given, we get from the displacement diagram, and actually we know that whatever is the distance, actually it is coming from the center position in this particular case of cam. Based on that location, actually the movement of the cam or the lift of the cam is there, okay, or the displacement. So whatever is this position, suppose this is the angle, this is angle, suppose 20 degree, 40 degree, suppose. So at this, when we meet the 20 degree, that means this location to this much is the lift. Similarly, suppose if it is 40 degree, then it is not actually 40 degree, but for the sake of understanding, we are just saying it. So when it cam rotates up to 40 degree, so this much is the lift. Similarly, in the next case, this much is the lift. Similarly, in the next case, this much is the lift. next this much is the lift, and so on. Similarly other for the others. Okay, during dwell there is no movement throughout the dwell. Actually this much is the lift, this much is the position. Okay, there is no movement but position is this much. So that is the thing. So what we are going to do, so this 1 dash 2 dash, this length 3 dash, etc. This length we have to calculate, measure, and we'll just extend in the same line, along the same line. Suppose if it is 1, so 1 dash, whatever is the distance or length we get from the displacement diagram, that must along the same line. Okay, you should not make it vertical, horizontal, something else. So whatever is the orientation of this line, along the same line you just have to extend by this much. So this is 1 dash position. Similarly 2 dash 2 dash, you will denote or you will measure from the displacement diagram, that much amount along the same second division you are going to extend. Similarly the case for 3 dash, 4 dash, etc. So it is along the same line just entry. So up to 6 dash we will do like this. Okay, so these are the positions for, and you will name them whatever name has been given previously, 1 dash 2 dash 3 dash, like that. And here it is ascent stroke is over. Next it is the dual stroke. So next, and already we have made the division, so at the end of dual stroke it is the same 6 dash length. Okay, and now after that we have got the descent stroke. So in the descent stroke, once again the length 7 dash, 8 dash, 9 dash, 10 dash, etc. You will just calculate or measure from there, and as that much extension along the same line you will just do this one, this way, or like that. Okay, and you will mark the point 6 dash, 7 dash, 8 dash, 9 dash, and up to this much you will just do. I hope up to this much it is clear to everyone. Just let me know, anyone.
Yes, sir. It's clear.
Okay, thank you. Okay, so now we just have the last step left. We just have to find out the cam profile or draw the cam profile. So now this location, this extended position, what does it basically denote? So actually it is nothing but we are saying that it is the, from here we are showing that we are taking this length from the displacement diagram, and in the displacement diagram and the look of the cam profile, cam, how does it denote? We know that the way the length is changing, the location of this particular cam and the follower with respect to the cam, because we already know cam and follower, they are in constant contact. Contact is not broken. So if that this is the location it comes to this particular position during rotation, so follower will be lifted by this much location. Similarly, if during the rotation it comes here, so follower will be similarly lifted up to this much. When it moves up to this much, okay, during the rotation of the cam, follower will move up to this much, and so on. Up to when 6 dash comes to this position, after rotation, if it is rotating like this, then the follower will be somewhere here. Okay, depending on the whatever is this particular distance. Okay, similarly the during that particular dwell it will remain there only. After dwell, during the descent stroke it will come down. Okay, and there again there will be dwell, so it will stop there, it will remain like that. Up to this much, I hope it is clear. So now what will be our task? As it is knife edge type of follower, so considering the starting point as the knife edge, because we already know the knife edge is directly in contact with the cam, so considering this point as the starting point, so all those 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, next once again 6 dash, etc., you are going to join them with a smooth curve. Okay, don't join like, suppose O dash, it is the O dash position, okay, initially, okay, suppose O dash, 1 dash, don't join them like this, don't do like that, but make the curvature necessary. So smooth curve, try to make smooth curve and join them. So this way we will just join the points. Okay, don't join like this, don't join like that, but make the curvature necessary. So this way will come and join the point, and this up to this much, this is the ascent stroke. Next, in the dual stroke we don't have any division, how to join them. So in that particular case, actually it is a constant radius curve. You can directly take this much as the radius and you can draw the a portion of the arc. Okay, you can just join them. So this is a constant radius curve. It will be concentric portion, concentric circle portion from here. Okay, next once again you will, with a smooth curve, you will join them. Okay, but after that don't leave it here. There is the last dual is there. Actually, once again it is already the circle portion only, circular portion, but make it dark. Okay, so this completes the whole cam profile, and after that you just show it like this. This is the required cam profile. So this is done. Understood? Just someone just let me know. This completes the cam profile consideration. How to draw the cam profile for this case. Anyone can let me know just whether you have understood or not. Please, someone please let me know whether how we have done, whether you have understood or not. I hope you have understood. So this completes the construction of the cam profile, and after that, just you have to find out the ascent and descent, so that velocity and acceleration. So for this particular case, omega equal to 2 pi n by 60 we already have, and omega will just find out. Okay, 12.57 radian per second. So during ascent stroke, it was SHM. Okay, similarly during descent stroke, that is uniform velocity. So considering the already known expression, we already have Vmax and acceleration maximum. Okay, we'll just put the values. Omega we just find out. H is given. Pi is pi. Angle is already there. But the thing is, you just convert it to radian. So for that, 150 degree into pi by 180, it makes it to radian. Okay, so that is the important. And just solve it. You'll get some value. 26.3 mm per second. Be careful with the values, whatever is being given. That similarly, F max, it is also SHM only. Okay, for ascent stroke. So use the corresponding formula. Okay, and once again, be careful. Okay, so this way you will find out. Okay, and be careful with the units. Okay, you have to always use the proper unit. Similarly, for descent stroke, during descent, it is uniform velocity only. So for that, you just use the corresponding formula and just find out. Okay, and if it is uniform velocity, there will not be any. It is understood. Uniform velocity means there is no acceleration. So acceleration value, maximum, minimum, everything is actually 0. Okay, so with this we stop here. We have completed this first question. In the next class, we'll be discussing the next problem. Okay, just someone please let me know whether you have understood, or if you have any question, you can just ask. In the next class, maybe today this time is also over. In the next class, we will try to discuss the question. Just if you have any question, ask me, or if you understood, just let me know. We'll stop here. Yes, your voice was actually distorted. Just can you repeat? Okay, understood. Okay, thank you everyone for joining the class. Hope you have understood. Just try this kind of problems. Okay, these are easy, but if you don't practice by drawing by yourself, by taking proper scale, then sometimes you may get puzzled. So thank you everyone for joining. I'll be uploading this recording in the this video. Okay, thank you everyone. I'll be stopping the meeting here. Thank you everyone for joining.